All right, so good morning, good evening, good afternoon, and welcome. So this is going to be chapter 1.2 and 1.4. We are kind of in the midst of learning this information, so I wanted to make sure I get this out to you guys. I kind of at the beginning of the year last year, I hadn't quite made these videos. These are fresh for 2019. So what I want to make sure you guys do is understand kind of how we're going to evaluate and do order of operations. Now, you've done order of operations your whole life. It's the PEMDAS, right? It's parentheses, exponents, multiplication, division, addition, subtraction. You guys can't see, I have a little PEMDAS thing up here that I keep above our board just to remind us. Okay, so we're going to evaluate an expression. So what does this actually mean? 3 to the power of 5 means there are 1, 2, 3, 4, 5 of them. Okay, so what you would do is start multiplying it across. Now, in class, we are going to I'll show one of these. So this would be 3 times 3, which would be 9. Okay, and then this would be 3 times 3 is 27 times 3 times 3. And then 27 times 3 is 51. No, that's not right. 71. So let me verify. Yeah, 81. Wow. Okay, 81 times 3 then ends up being your final answer, which is going to be 243. Now, this is hard to do when you're doing this mental math like that. So, sorry, that's supposed to be a 3. One way easier to do it is just use a calculator in this instance. So it would be, so the next one, 2 to the power of 5, it's going to be 32. 4 to the power of 3 is going to be 64. And then this would be 5 fours. So 5 to the power of 4 is going to end up being 625. So the goal is to make sure that you guys can actually figure out how to do this order of operations and evaluate it effectively. But tell me what it actually means. That's what I need to make sure you understand. That 3 to the 5th means there are there are 5 3s and they're all multiplied together. Okay. So now we're going to do evaluate expressions. So you need to do grouping first, evaluate the powers, multiply or divide, add or subtract to left to right. Okay, so first and foremost is see if there's any grouping. So like for letter A here, are there any groupings here? The answer is no, there is not. Okay, so next step, evaluate the powers. So you have a power here, 2 to the power of 4. So it'd be 16 minus 8, and then it's divided by 4 plus 14. And then it says multiply or divide from left to right. So you got to look on here and make sure you're doing the correct order. Now you multiply or divide. Forget the outsides. It's negative 8 divided by 4. Negative 8 divided by 4 is negative 2. Then you drop the 16 and you drop the 14. Now you subtract left to right. Okay. So 16 minus 2 is 14 plus 14 is 28. So if you guys want to know, this would be dropped down to get 28. All right, simple thing. Make sure you guys can do it. Now let's work on the other one over here. Same thing. No powers, no grouping, multiply or divide. So this is negative 42 is divided by 3. Okay. It's been a long day, so let me put this in. It is negative 14. So it's negative 14. It's 10, and it's plus 8. So 10 minus 14. So remember, this is 2 different numbers. So it's 10 minus 14. It's negative 4 plus 8, which is 4. Okay, so make sure as you're grouping this that you guys use the correct order and you understand the philosophies. Okay, now what I want you to do is use the grouping aspect of it, where it talks about expression with grouping. Work on the inside first. Start with these parentheses first on the inside, then do powers. So try first and see what you guys can get. All right, so let's rock and roll in this. Grouping. 10 minus 4, or 10 minus 6 is 4. So it's going to be 4 divided by 2 plus 5 times 4. All right, so that's your setup. Now you do division and multiplication from left to right. So it's 4 divided by 2, 2 plus, and then it's 5 times 4, which is 20, which equals, of course, then 22. Same thing, start with inside the parentheses first. So you start within here, Then you got to get rid of the exponents. So it's going to be 6. You got a bigger bracket, 24 minus 5 squared. And then, let me rewrite that one. Okay, so this is going to be big bracket, 24 minus 5 squared with another big bracket. Then you do the square power on the inside. So this is going to be 6, and it's going to be 24 minus 25. Solve for inside the brackets. 6 times -1, which is -6. Okay, so make sure when you guys are going through this that you work on solving inside any parentheses first, and then you do the power aspect of it. So you wouldn't actually multiply this or add these together and then subtract and then do the power, because the power is only associated with this number right here. So please make sure as you go through that you guys do the right order of operations. Okay, so here are 2 other challenging ones. Make sure you guys can do it. So same thing, as you work, power for grouping. No grouping, so you work on the powers. So this is going to be 6 minus 2 times 2 is 4 times 2 is 8. That's 3 times 4 divided by 6. Okay, so now you work left to right, multiplication and division. Now I can do the top as well, because it doesn't matter at this point that this and this are different orders of operations, kind of. So 6 minus 8 is going to end up to be -2 over 12 divided by 6, which then is -2 over 2, which ends up being -1. All right, so that's an order of operations kind of in the sequence. So same over here when you're working on this. This is a larger equation, but you need to take it down by bits. So first, inside parentheses, okay? You want to focus mainly on these parentheses right here. So 5 plus 2 is 7. So you would rewrite it. 12 minus 2, with a bigger bracket, 52 minus 7 squared plus 2. Sorry, my voice is dry now. Now you work on the power part, right? So 7 squared is 49. Okay, now you have parentheses still. You need to solve within the parentheses. So you'd end up with 12 minus 2 times, that's 52 minus 3 is 3, plus 2. Now you multiply. So it's -2 times 3, which is -6, plus 2. And you'd end up with 12 minus 6, which is 6, plus 2 equals 8. So there's your actual number on that. Okay, so we are going to have homework related to this, and I'll make sure you guys get it on the quiz that we're going to have and the test that we're going to do later in the week. We will be doing a lot of order of operations, so make sure you guys are doing it in the correct order. All right, 1.4, distribution method. This method is just kind of another way to explain a couple different things to you guys, and for you guys to understand kind of how you do evaluations, okay? Once you guys talks about John burns, he burns 420 calories. So that's an important number, so I'm going to make sure I write that down here, 420. He does per hour surfing. The chart below shows the time he spent surfing in 1 week. To determine the total number of calories, you use the distributive property. So what they're saying is there's 2 different ways of actually doing this property, okay? First would be to take and add up all the hours together, okay? So you take 420 and you multiply it by the 1 plus a half. And then it would be, we don't need to put plus 0, but it'd be plus 1 again, plus 2, and then plus 2 and a half. And then what you do is add them all up. So this would be 1, this would be 1 and 2, 3, 4, 5, 6, 7. So this would be 420 times 7, and if you do that in a calculator, you'd end up knowing that this gentleman burns 2,940 calories. Now, what is the other distribution way of doing it? The other way is a little harder and a little longer, but it wants you guys to know the same process, okay? So what I mean by that is on this process you would take and you would multiply this out. So that instead of being at 1, it would be 420 times 1 plus, and then it would be 420 times 1/2 plus, and then it would be the same thing again, 420 times 1 plus, and you guys get the drift, how it works out. Then you would multiply everything out, but you would end up still getting the same answer. I don't really want to work on that method too much. I would prefer you guys to understand the aspect of adding everything together and then multiplying it out for that particular example. But when it comes down to here to the distributive method, it talks about either method can be used the same, it's just how you actually determine. You guys learned the distributive property differently, where you may have done the rainbow method to multiply in. So you have A on the outside times B plus C. And what you do is you would do the rainbow method. So you would get rid of the A, multiply it by B, multiply it by C, so you'd have AB plus AC. Hopefully you guys understand that and realize you can write it either way. It doesn't really matter. So you see here, 3 times 2 is 6, 3 times 5 is 15. You add it together, you get 21, or you could add it in the middle. It's up to you. It doesn't really matter at this point. All right, this distributive property. Okay, here's another real world example in relation to this. Make sure you guys are fully aware of the setup here. Okay, if you're buying tickets, so a group of 7 adults and 6 children are going to the University of Florida Bulls game, use the distributive property, write and value the expression for the total ticket cost. One aspect that's missing here is the actual chart, okay, which was not put on here. The chart that was not put on your notes basically says that an adult game, so we're looking for a group of adults. So a single cost for a group, adult single, is $5, okay? Children single is $3. And then it talks about groups of 10 or more is $2. And then senior groups is $3. Okay, so there's our chart that we were not given, so now we can try to figure out the cost. So a group of 7 adults. So we have 7 adults that we'd write down, okay? They are charged $5 each, and 6 kids, which are charged $3 each, and I spelled misspelled, misspelled that. So now you do is you do the distribution property, right? So 7 times 5 is 35, plus 18, which comes out to be 53, okay? So that's how you would use the distribution property. Make sure you guys understand the setup and understand how to do it. It's kind of simple, common sense math, but I know some people might struggle, okay? So use the distributive property to rewrite this and then evaluate. So what this is talking about is some of us might struggle to know how many of you guys know right away what is 6 times 29? Most of us probably don't know what that is, okay? So what it's trying to tell us is, do you know what 6 times 30 is? Well, some of us should, because 6 times 3 is what? 18. And then you'd add a 0, so there you go. So what's the difference between 30 and 29? It is how many 6s? 1. So what it's doing is it's telling you to evaluate to the closest number, subtract 6, and you get 174. So 29 times 6 is 174. What this is doing mental math quickly and trying to get you guys effectively thinking, okay, I can do this, I understand. Now on this one, it's the same setup. It's not close to 30, but what it wants you to do is evaluate, can you rewrite this using a distributive property and then evaluate? One way of doing it is to break this 30 up. So you can go 5 times 30, and you could go 5 times 4, right? So what is 5 times 30? Everybody knows this is 150. And then it would be plus 5 times 4, which is 20, which is 170. How many of you guys knew that 34 times 5 is 170, just like that? We didn't. That's what the distributive property is doing here, okay? Is it's evaluating things, changing things up, making it so you can do mental math quicker and more effectively. All right, evaluate these expressions. So what I want you guys to do is go through these, try to figure it out yourself. So I'll do This A, you're going to do B, I'll do C, you do D. Okay, first things first. Multiply it in rainbow method or distribution method. 7 times 3 is 21. W minus 35. Okay, can you simplify these things together? No, because you cannot combine a W with a 35. Distribute this out. All right, so you have 12x squared plus 12x minus 20. Can you combine like terms? No, you cannot. Because x squared means there's like bundles of pencils. 2 bundles of pencils, there's a bunch of them. This would be like single items, and then this is just a number. You can't combine like terms from that aspect. They have to have the same variable, okay? C, do the setup. Now you're distributing a negative into here. So negative 2 times 3 would be, what I like to show my students is kind of over here in the margins. It'd be negative 2 times x times 3 times x, and then there's 2 of them, so that's how you would write it, x squared, okay? So this is this equation right here. So what you do is you multiply the numbers out first. So negative 2 times 3 is negative 6, and then how many x's do we have now? 1, 2, 3. X to the third. Okay, we don't write negative 6 times x. We don't write it like that. You would write it to x to the third. Okay, now, same here. Negative and a negative is going to be positive. That's 8. And then how many x's do we have? 1, 2. And then the last one is negative and a positive is negative. Times 1 is, there's your answer. All right, what I want you to do is try that one real quick on your own. All right, you're going to do the x squared. Remember, x squared is the same as saying x times x, right? So if I multiply this together, 4 times x times x times x, I now have how many x's? 3. Okay, this would be coming in. You just basically say negative, because there's no change. I would change the sign 2, and then it'd be yx squared, or you can go 2x squared y. All right, preferably speaking, in terms of writing, this bottom one would be better because you usually want to have more exponents to the left to right, okay, as you read it. And then this last one here would be plus 9x squared. So be prepared to see either this or this. Most likely, ladies and gentlemen, it will be this bottom one right here because of how orders of operations line up and exponents line up, okay? So last piece on this is making sure you guys understand like terms, okay? This is 3 terms, squared, x, 4. These are like. See, it has a squared, but these aren't alike because this is squared and that's an a. So now it's combining like terms. So here is where we started talking about from the previous lessons about understanding positives and negatives. That you're putting the 2 numbers together, you're not multiplying or dividing. Okay, so what you guys can do is the circle square method or box if you want. So it's a box, circle, and a triangle. You can box all of the squares, and you should do the term in front of it. Okay, I have an X here, so let me circle. So I can change colors. So I'm going to change colors on this one too. So this would be a circle. This would be a circle, and then the last piece here would be a triangle. So it would be a triangle like that and a triangle like that. So what you're doing is you're putting all the shapes together, right? So let's think. We need to do the squares first. So 2 plus 3 would be 5x squared because the back end doesn't change, okay? Remember what this is saying is you have x squared plus x squared. You can't change the variable when you're adding together, okay? Then it'd be plus 3 minus 8 is negative 5. That's an x. And then it's plus 8 over here. It's 10 minus 2. All right, same thing. You need to multiply this out first. So it'll be 2x plus 10 minus 5x minus 8. Then you can do the setup where you change things around. So this would be a box. This would be a box. And then I don't have to do anything with the other ones. So 2 and a negative 5. Negative 3x plus 2, because 10 minus 8. Letter C, same thing, okay? Multiply these out. So this would be 2a squared plus 12a, and then this is going to be minus 3a squared, and then negative and a negative is going to be a positive 21a, okay? Make sure you guys follow along on that aspect as you go through it. Now you combine like terms. 2 and a 3. Negative 3 is negative a squared plus plus. So you're going to add, and it'd be 33a. Okay, so there's your answer there. Over here, you do the distribution as well. So it'll be y squared x plus y to the third, because that's 1, 2, 3. And then it's minus. Now, I start with a minus, but negative and a negative is what? Positive. So this is actually going to be 3y to the third. But this is going to be minus. It's going to be positive. It's going to be 30x squared y. And does anything here match up? Okay, I have a y to the third. I have a y squared. That doesn't match. But I do have the middle terms. So you end up with y squared x plus 4y to the third minus 30x squared y. Okay, so that would be your final setup on that equation. Can you combine like terms any farther than that? No, you cannot. So please make sure you guys are fully aware. Last thing, algebraic expressions. Okay, twice the difference of 3x. So make sure as you guys write these through that we work and get things quickly done and going from there. So let me see here. Use the expression twice the difference of 3x. So it's going to be twice the difference of 3x and y. Difference is subtracting. Increased should be adding by 5 times the sum of 2x plus, or 2y plus x. Does it matter how I wrote that? Really doesn't. But that would be the setup. Now you basically rewrite it. There's write an algebraic expression. I don't want you to solve it at this point. If I asked you to, you could. Okay. So I can solve it out real quick. If I wanted to, it should be multiplying. So this would be 6x minus 2y plus 10y plus 5x. Combine like terms. So this would be 5 and 6 is 11x. And then this is going to be plus 8y. 4 times the sum of 2x and 4y minus the product of 3x and y. So this would be 3x and y. Okay, so there's your setup on those. All you would do with this one, ladies and gentlemen, just making sure I wrote it right, multiply this one out as well. So this would be 8x plus 16y minus 3xy. And then, ladies and gentlemen, can you combine anything else in this category? The answer is no, you cannot. All right, so this video was long, but it's actually a 2-day lesson. So make sure that you get the homework from me, complete the order of operations as quickly as possible, and make sure that if you have any questions, you come see me in class, okay? It's been a pleasure teaching you this time, and I look forward to seeing you in class soon.